3.1 functions, a couple definitions, starting out with a relation. A relation is something that pairs inputs with outputs. So a good example in math of pairing an input with an output is usually an ordered pair, such as x comma y. Your input is going to be your x value, and your output is going to be your y value. Now, specifically, when we talk about a relation or something that pairs an input value with an output value, a very, very special type of relation is what we call a function. And a function is a relation that pairs each input with exactly one output. Okay, and the key here is exactly one. So a relation, you compare any x with any y as many times as you want. You have an input, you have an output, whereas in a function, it has to pair exactly each input with exactly one output. So let's look at what we're talking about here. Number one, determine whether each relation is a function, and then kind of explain where we're coming from. So if we're talking, we've got a whole bunch of x, y, x, y, x, y, x, y, x, y. Now, each input has to be paired with exactly one output. So my input is -5, and that's being paired with 0. Here my input is 0, and that's being paired with 0. Here my input is 5, it's being paired with 0. Here my input is 5, and it's being paired with 10. Now, it specifically talks about the input. So I'm focusing here, 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 and here. And it says that each one of those inputs can only be paired with exactly one output. So specifically, that kind of keys me in here, because do you notice that your input is kind of doubled up? You have a 5, and you also have a 5. Well, if each input has to be paired with exactly one output, well, that's not exactly one, because 5 is being paired with 0, and 5 is also being paired with 10. So my input value of 5 is not being paired with exactly one output value. It's being paired with two output values, both 10 and 0. So this is not a function. Yes, it is a relation, but it's not a function. Okay, and then this is from a set of points. This is one way we can tell whether something is a function or not, and it's from a set of points. So let's try this again. Here I have a -4, a -1, a 2, and a 5. Those are my input values. So I'm looking at my inputs and I'm going, okay, -4. Do I see another -4 as an input? It doesn't matter as an output. I'm just focusing on the inputs. Well, that's my only one, and it's being paired with exactly one output of 8, so that's okay. -1. Do I see any other -1s as an input? No, so that's exactly being paired with 2. That's okay. 2 is being paired with -4, and I don't see 2 being paired with anybody else. And 5 is being paired with -10, and I don't see 5 being paired with anyone else. So yes, this is a function. Letter C. Now, the first two examples were identifying a function from a set of ordered pairs. This is from a table. So this is another way that we can identify a function. Now, this time, these are your input values over here. Those are your x's. These are your output values. Those are your y's. So here I'm looking at 2. Is 2 being paired with exactly one output value? Yes, it is. And there's no other 2 over here that would be paired up with somebody else, so far so good. 4 is being paired up with an output of 5.2, and I don't see any other inputs of 4. So he's got exactly one output value, and the same with 6. 6 is being paired up with 7.8. It's only being paired up with 7.8. So yes, this is a function. Letter D, input 1/2, output -2, 0, 4. So our input has to be paired up with exactly one output value. Well, how many output values is 1/2 being paired up with? Well, it's being paired up with 3. It's 1/2 -2, 1/2 0, 1/2 4. This is not a function.